Hello guys, we are back with our next lecture. In this lecture, let us go through the concept of a Cayley Hamilton theorem, guys. So in some kind of questions, he will be giving a matrix A and he will be asking us to find some power A power 4 or A inverse or A inverse cube. In that way, he'll be asking, right? So these questions seems to be easy, but when you start solving them like multiplying it 4 times and all those things, it will slowly get complex, guys. So that is the reason why we will be using this Cayley Hamilton theorem. So if for A for you to see that okay, I'll calculate, there's no issue. What if I say for A44 I want, for A50 I want, A100 I want? It will be really complex, right? As the number increases, the complexity will increase or double, or it will increase exponentially, right? Yes. So that is the reason why we will be using the concept of Cayley Hamilton theorem to solve this, guys. Okay. So the first step is nothing but you will be finding the characteristic equation. So I hope everyone knows how to calculate the characteristic equation. So indirectly you will be multiplying, you will be doing the you will be performing this operation on your matrix A minus lambda I equal to 0. Guys, I have already discussed about this method in the last lecture. If you did not watch it, please watch it, guys. Okay. Yes. So we will be getting the lambda values and then you will be replacing with lambda by A, and then we will be doing our respective values. We will be searching. Okay. Yes. So now let us go through a problem. Okay. So here he gave a matrix. Then he is asking A inverse and he is asking A power 4. Okay, so those things seems to be easy, like you can multiply it 4 times and you get this result, right? Yes. So you'll be saying that it's simple, but if this matrix is having some big values, that could be an issue, right? Yes. So in those situations, this method will help a lot, guys. Okay, so the first step I told you, you need to find the characteristic equation. So again, do the same, that is nothing but in diagonal minus lambda minus lambda minus lambda. Now you do the det operation. So det operation, here I took this row. Okay, so using that I have just calculated it, guys. So at the end I got an equation. Okay. So you can just pause the video and do it step by step, guys, because okay. So solving it step by step will take some time, so that is the reason why I'm just saying you as a theory. Okay. Yes, so you can just solve it and you'll be getting this exact result, guys. Okay, so now replace this lambda by A, guys. You'll be getting this as an equation. Okay, so if you observe here in this equation, are we having A power 4? No. Are we having A lambda? Sorry, A inverse? No. But we can do some kind of changes to get it right. Yes. So that is the thing that we will be learning here. Okay. So first we know A value and we know I value. So first calculate A square value, guys. So A square is nothing but A into A. So you'll be matrix multiplication. I hope everyone knows, right? So this into this will be your first value. This into this will be your second value. This into this will be your third value. This will be your this value. This into 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 this will be your this value. Like that, you'll be doing the matrix multiplication. Please cross check it, guys. Okay. So once the matrix multiplication is done, so now you know A value, A square value. So now let us find A cube value also. Okay, so you might be saying that why I am finding all these things, you might be thinking, right? Yes. So I want to find the values in this equation, guys. So I know I value, I know A value, now I know A square value. Similarly, I'll be calculating A cube, so I also got A cube value. Okay, so once I got it, I'll be substituting in this equation, guys. Okay, so now I concluded that the value that at the end I got was 0. Hence you can say that the Cayley Hamilton theorem was proved. So basically solving this all process is not needed, guys. I am just checking it, because based on your marks, if it is given as a direct LIQ for 15 marks or 10 marks, only finding those values will not be enough. You need to verify it first of all. If it is given for 5 marks or 3 marks, directly you can do it. Okay. Yes. So now to find A inverse, what can we do for this equation? Just to divide it by A. What is there in that, right? Yes. So just to do that, guys. So if you do that, you will be getting A square minus 6A plus 9 minus 4A inverse, right? Yes. So now you need to find this. So let us push all these to the other side. So 4A inverse is equals to A square minus 6A plus 9I. Okay. Yes. So I pushed this side. Okay. So that's the reason why I got plus 4A inverse. Okay. Yes. So we already know the value of A square. We already know the value of A, and we already know the I value. So substitute them. Okay. So substitute them and solve it. At the end, you will be getting the A inverse value. Okay. So we got the A inverse value. Similarly, to find A power 4, just to multiply with A, guys. So if you multiply, you will be getting A power 4 minus 6A cube plus 9A square minus 4A. Okay. So now just to substitute the values of A cube, A square and A. Okay. So you solve it, you will be getting the value of A power 4, right? Yes. So I hope everyone got some basic idea on this, right? Yes. So this is all about Cayley Hamilton theorem, guys. I think there are around 5 to 6 examples in our classwork. So please go through them once, guys. Because if you solve more and more examples, only you can just have a clear idea on these problems, guys, because these problems might confuse you in the examination. Okay, so there are around 5, 6, 7, 8, 9. Okay, so we are having around 10 problems, guys. You can just go through them from the classwork. Okay, so in the next lecture we will be going through the diagonalization of matrix, guys. Okay, yes, so let us meet in the next lecture. Thank you, thanks for watching.